Hello students, welcome to part 2nd of chapter 1 of your science book, which is matter in our surroundings. In this video we shall discuss about the temperature convergence and the interconversion of matter from one form to another and the terms which are associated with it. Let's take a look and listen to it carefully. Scale of measuring temperature. Before discussing the scales of measuring temperature, we shall know what temperature actually is. So students, the degree of hotness or coldness of any body is known as temperature. And temperature is measured by an instrument which is known as thermometer. As such, there are three scales of measuring temperature: the Celsius scale, Fahrenheit scale, and Kelvin scale. The temperature on Celsius scale ranges from 0 degrees Celsius to 100 degrees Celsius. If we have to convert a temperature in degrees Celsius to degree Fahrenheit, then we multiply that temperature by 9 by 5 and add 32 in the result. If we have to convert degree Celsius into degree Kelvin, then we add the temperature in degrees Celsius to 273. So there are some examples which you have to do, and you have to convert the following temperatures to degree Kelvin and to degree Celsius respectively. Now, can matter change its state? Water can exist in three states of matter: solid as ice, liquid as the familiar water, and gas as water vapors. The difference in these three states of matter is due to difference in the spaces in between the constituent particles and the interparticle force of attraction that exists between them. This interparticle space is inversely proportional to interparticle force of attraction, and change in one of this can lead to the change in the states of matter. Students, there are two ways to achieve the change in the state of matter. The first one is by changing the temperature, and the second one is by changing the pressure. Let us discuss the effect of change of temperature. First of all, if we have to convert the state from solid to liquid, then the process or phenomena is called melting. When the change of state takes place from liquid to solid, the phenomena is called freezing. The change of state from liquid to gas is called boiling. And the change of state from gas to liquid is called condensation. And these are the common phenomena which happen in our day-to-day life. Let's discuss about melting. First of all, we are having a solid. We heat that solid. What happens when we heat that solid? The temperature increases. We know that kinetic energy is directly proportional to temperature. So when the temperature increases, obviously the kinetic energy will also increase. Then when the kinetic energy increases, the particles start vibrating with greater speed. This decreases the force of attraction between the particles. And particles, they are forced to leave their fixed position. When they are forced to leave their fixed position, they start flowing. As a result, the solid melts and it is converted into liquids, because we know that fluidity is the property of liquids and not solids. So whole phenomena is called as melting, and this is the pathway by which melting takes place. Now, definition of melting point. Students, the temperature at which a solid melts to become a liquid at the atmospheric pressure is called melting point. So it is the temperature at which solid melts into liquids. The process of melting, that is, the change of solid state into the liquid state, is also called fusion. And students, the amount of heat energy which is required to change 1 kg of a solid into liquid at its atmospheric pressure and at the melting point is called latent heat of fusion. Latent heat of fusion converts whole of the solid into liquid without raising the temperature of that particular system. Latent here means hidden heat. Therefore, this heat just converts one state to another and does not lead to an increase in temperature on the thermometer. Moving ahead, the next process is freezing. Freezing is the conversion of liquid state to the solid state. and it can be accomplished by decreasing the temperature. We are having a liquid system, we do its cooling. As a result, the temperature decreases. Due to decrease in temperature, the kinetic energy also decreases. Particles stop vibrating and their speed decreases. It increases the force of attraction between the particles, and particles come closer to each other. They start moving slowly. Initially, they were moving very rapidly. And if the temperature is lowered further, attractive force of the particles pull them more closer to each other, and the motion of particles ceases. As a result, the substance freezes. So this is the pathway by which freezing occurs. Definition of freezing point. The temperature at which a liquid freezes to become a solid at atmospheric pressure is called freezing point. The process of freezing, that is, the change of liquid state into solid state, is also called as solidification. Effect of addition of impurities on the freezing point. So students, if you're having impurities in a system, then impurities lower the freezing point of liquids. For example, 30% of calcium chloride in water freezes at 218 Kelvin as compared to a solution of sodium chloride in water which freezes at 255 Kelvin. Boiling, conversion of liquid state to the vapor state. We're having a liquid system, we do its heating. As a result, temperature increases. When temperature increases, kinetic energy increases. The particles start vibrating with greater speed. It decreases the force of attraction, and particles in turn start moving more faster. If temperature is increased further, the particles leave their place and the substance boils and a liquid is converted to its gaseous state. Definition of boiling point. The temperature at which a liquid starts boiling at atmospheric pressure is called its boiling point. Each pure liquid has a fixed boiling point. For example, pure water has a boiling point of 373 Kelvin, which is equivalent to 100 degrees Celsius. Higher the boiling point, students, higher will be this force of attraction. Volatile liquids, which convert directly into vapors at a very low temperature, they are having low boiling point because of weak forces of attraction. For example, ether, which boils at 308 Kelvin, acetone boils at 329 Kelvin, and alcohol, it boils at 351 Kelvin. The non-volatile liquids are those liquids which are having high boiling points and strong forces of attraction. For example, glycerol, glycerine, etc. What is latent heat of vaporization? Temperature will remain constant during boiling. Where that heat will go? Because earlier also we said that latent heat is that heat which is basically converting one state to another, and it is not playing any part in increasing the temperature. The amount of heat energy that is required to change 1 kg of liquid into vapors completely at atmospheric pressure and at its boiling point is known as latent heat of vaporization. Effect of impurities on the boiling point of liquid. Boiling point of pure liquids is always fixed. But if we add salts or other impurities to a liquid, then it increases the boiling point of that liquid. For example, 60% solution of urea raises the boiling point of water by 0.52 Kelvin. Effect of pressure on the boiling point of liquid. The boiling point of liquid depends on the pressure acting on it. If the pressure is increased, then boiling point increases. And if the pressure is decreased, the boiling point decreases. At sea level, water boils at 373 Kelvin, where pressure is 1 atmosphere. But on mountain side, it boils at low temperature because pressure at mountains is less than 1 atmosphere. And inside pressure cooker, it boils at high temperature because inside pressure cooker, the pressure is more. Condensation. Change of gaseous state to liquid state is called condensation. This phenomena is very well explained if you take cold water inside the glass. After some time, you will observe water sticking to the glass. This is because the water vapors which are present in atmosphere, they get a cold temperature or they get a low temperature and they get condensed. These water vapors change to the liquid state. When a gas or vapor is cooled by decreasing the temperature, the kinetic energy of their constituent particles is decreased. Due to that, particles start moving slowly. As the temperature is further lowered, the attractive force pull the particles close together and the vapor condenses. That is, gas or vapor is converted into liquids. The same phenomena of condensation is observed in case of clouds also. At higher altitudes, the temperature is low. Water vapors, they get condensed on meeting such a low temperature and they get converted into liquid, and this liquid is showered upon the earth's atmosphere in the form of rain. So students, this was all about this lecture. Hope it is clear to all of you. In case you have any doubts, you can post it in the comment section. Thank you so much.